Here we're doing practice problem 7.15. Now here, again, the switch closes at t equals 0, and the capacitor node is initially going to have 0 voltage. So once we, nothing's going to flow. But again, one of the things you always want to take a look at is the op amp. This V plus is grounded. That means this is going to be grounded. It's 0 volts. So when I close this switch, current's going to start to flow. And we're going to call this I1 through this resistor. Now as the current flows, we note that none of it can flow into the minus, so that all the current's going to flow up here. So what that's going to do is split between the capacitor, IC, and the resistor, IR. So our nodal currents we can write is I is equal to IR plus IC. Now I1 is going from this 4 millivolts to ground. So we have 4 millivolts is just equal to I1 times 10K. So I1 is equal to 4 millivolts over 10K. Okay, now we can also write that as equal to the voltage, the current IR is just, note the voltage across the capacitor is same as that of across the resistor, and we'll call that V. So that's across the resistor IR, that's just V over the resistance, 100K. And then we have plus the current through the capacitor, but we know that's just C dV dt. Okay, now we have our differential equation, and if we multiply everything through, we're going to get by 100K V plus 100K times 1 microfarad, that's 10 to the minus 6 dV dt, is just going to equal to, and that's going to be 100K over 10, so that's going to be 40. That's 4, that's 10 times 4, 40 millivolts. Okay, now to solve this, we know that we need to find V is equal to V infinity, and V infinity is when this term here is equal to 0, or in other words, V infinity is equal to 40 millivolts. Okay, V0 we said was 0, and therefore we can find the solution, which is across the capacitor anyway, is V is equal to V infinity 40 plus V0, 0 minus V infinity 40 times e to the minus t over RC. Well, RC is 10 to the 5th times 10 to the minus 6, so RC is equal to 10 to the minus 1, or 1 over RC is 10, e to the minus 10t. Okay, but what about V0? Now we have to go back here and take a look. We note that if we do this, V0, if I start here at 0 volts, V plus V0, I get back to ground, that's equal to 0, or V0 is equal to, or V0 is equal to minus V, which is equal to minus 40 plus 40 e to the minus 10t. And there's your answer.